Okay. In this one, let's talk about percent composition. I got my trusty friend here to help us out. Can you see? Want to come see? He's right here. Okay. Don't get in the way. Anyway, percent composition. All right. This is a skill we're going to need in order to figure out formulas, right? Because we're going to have to use this. This is kind of some of the data that we're going to deal with as we see stuff. Okay. So we've got mass percent. Oh, don't click stuff. Okay. Mass percent. This is how we're going to figure out, this is the unit we're going to use. Why are you clicking stuff again? Or percent composition. Okay. Officially, percent composition is just a list of all of the mass percent of each atom in the sample, right? So as with any percent, this is the mass, well, it's by mass. So the mass of a part of the sample divided by the mass of the total multiplied by 100. So in this case, what we're thinking of, we're talking about the mass of an element in the compound divided by the mass of the compound, okay? The way we're going to handle this is we're going to use determining the molar mass as a way to figure this out, okay? And then we'll need the mass of each in the formula, okay? So what we're doing is we're seeing where the data comes from in terms of this, and we'll use percent composition later to determine what the formula is. So here we're looking at how to use the formula to get the percent composition. So here's our example. Let's look at this dibromodichloromethane and figure out what its percent composition is. So we're going to need percent chlorine, percent bromine, and percent carbon in this thing to get it. It's kind of a whale of a problem, okay? Just because that was a horrible segue, you can know that the secret word for this is whale. And we'll just leave it at that. All right, mass percent. So we need a periodic table to give us molar masses of stuff. I don't expect us to know atomic masses of elements off the top of our head, okay? We're going to do this as if we're figuring out the molar mass, because we're going to need the molar mass for this guy as we go. Okay, here we go. So we have one carbon, so it's going to be 1 times 12.011. And you can do this in AMU or grams. Since it's mass, I'm going to go ahead and put grams here. You can put grams per mole there. It's fine. You'll get the same number. We have 2 bromines, so that's 2 times 79.904 grams. And we have 2 chlorines, so that's going to be 2 times 35.45 grams. I should put that 0 in there, so remember that that has 5 significant figures. All right, so this is 12.011 grams. Then we have, pardon me while I do this, 2 times 79,904 is 159,808 grams. And then 2 times 35.450 is 70.900 grams. All right. Now, to get the molar mass, and we've done this before, take your numbers and add them up, and that total will give us the molar mass here. So 12.011 plus 159.808 plus 70.9 is 242,719. This has units of grams because that's what we did the problem in. All right, this is our molar mass, which I'll usually abbreviate as MM. All right, what we need now is we need the percent of each element. And please read the questions carefully because you don't, what's going on? You don't have to do everything for everything. You can do just one specific element. So I could have said, do what's the percent chlorine in this compound? You would do this, but then you would only have to figure it out for chlorine. Okay. Here, I'm gonna do it for all of them so we see it. Okay. So our percent carbon is 12.011. This is the mass of the compound. Ah, shoot. 12. There it is. This is the mass of the element divided by the total 242.719 grams. That whole thing is times 100. Okay. That is 4.985. Oh, we need one more. 2% carbon. Okay. Let's do bromine. So our percent bromine is going to be 159.808 grams divided by the same total, 242.719 grams times 100. My periodic table's in the way. 159.808 divided by the total times 100, 65.84. And we need 5 significant figures, so 65.84. Oh gosh, 841% bromine. And then we can do chlorine. Our percent chlorine is going to be 70.900 grams divided by our total, 242.719 grams times 100. Why do I do that? 100. All right, 70.9 divided by 242.719 times 100, because I'm lazy. 29 point. We have 5 significant figures. 29.211. Okay, this is chlorine. Now, remember, your total has to be what? What does our total have to be? If we're doing percentages, our total has to be equal to 100%. Okay. So a good double check would be to add the 4.98 plus 65.8 plus 29.2 and hope we get up with 100. Okay. I'll let you double check me. Thanks for putting up with me, and let me know if you have any questions or need anything. I am here.